All right, y'all, we're ready to go on to the next section of our study guide. And so this is section 1.3.2. And in this lesson, we looked at different types of hearing tests. And we looked at the conductive hearing tests using tuning forks. Remember, the Weber test is the one where you strike the fork on an elbow or a knee, you put it in the middle of your head, and your patient should hear bilaterally. And you could put it on the forehead, you could put it on the bridge of the nose, or you could put it on the teeth for the Weber. The Rene, you're looking at one specific ear. So you use your tuning fork, you strike it, you're going to place it on the mastoid bone, which is right behind the patient's ear. Remember, you have to have it turned a specific way. And you tell them to lift their hand or signal some way when they no longer hear the tuning fork through the bone. And then you immediately move it next to their ear. And you time how long it takes them to tell you that they no longer hear it, both with the bone on the mastoid bone and on the air conduction right next to the ear. Evaluation, the air conduction portion, the time should be twice as long as the bone conduction portion. And that can be an indicator of types of hearing loss. With conductive hearing loss, they should hear it through the bone more for longer than through the air. And with sensory neural, potentially the times for both bone and air are shorter than normal, or the air conduction is not 2-to-1 for the time over the bone. Okay, when you're employing the Rene test, you find that your patient hears sound against her mastoid bone for 28 seconds, and then next to her ear for a further 18 seconds. This is not normal. What should it be? Again, the ratio should be 2-to-1. They should hear it twice as long with the air conduction portion than they did through the bone conduction portion. And this could be an indicator of sensory neural hearing loss, that there's nerve damage. They can hear it through the bone, but there's nerves that are not allowing them to hear it with just air conduction. All right, speech and noise. Remember, this is where you have a lot of background noise and you're asking a patient to pick out specific sounds. So this can be helpful in determining how well a patient will understand speech in a noisy environment, like a crowded restaurant being the classic example. And when you're doing the evaluation, the patient should be able to understand 50% of the script that you read to them at about 2 to 3 decibels louder than the background noise. And so if you have to read it louder, if they miss more than half of the script at anything less than 7 to 15 decibels, that would be considered about moderate sensory neural hearing loss. Okay, when you're doing the speech and noise test, you find that your patient is only picking up 30% of the sounds that he heard with speech and noise as when the test was administered in a silent environment. This is not normal. What type of hearing loss does this indicate? Again, this would be sensory neural. So they could potentially find some use in hearing aids, but hearing aids, they have their drawbacks. They tend to amplify all the sounds around you, not just a specific sound that you want. So it would there'd be more to it than just saying, oh, you need hearing aids. Okay, pure tone test, and these are the gold standard for actually identifying what frequency of sounds a patient is having difficulty with. Instruments needed, you would need some headphones for the patient, you would need a computer program, or you might have an old-fashioned actual box that is able to play different frequencies, and you need to know those frequencies. You need to be able to say this is 4,000 hertz, this is 250 hertz. And you need the ability to increase or decrease the volume of the sounds in measurable decibel levels. So you need to be able to graph. You need the graph to be, again, for an audiogram, is going to be frequency in hertz graphed against volume in decibels. Okay, pure tone test. So normal, mild, moderate, and moderate to severe hearing loss in decibels. Anything between 0 and 20, if they can hear it, that's normal. That's what we want. If it's between 21 and 40, that would indicate mild hearing loss in decibels. Moderate is 41 to 55, and moderate to severe would be 56 to 70. Okay, and here's an example of an audiogram reading. You can see that you have an elderly gentleman who tells you he has twin grandchildren. One's a boy and one is a girl. We're going to assume that these are teenagers because if they're both children, then the boy's voice will be rather high as well, high frequency. He reports he has no trouble hearing and understanding the boy, but he has to ask his granddaughter repeatedly to repeat herself. And what kind of hearing loss has occurred? Well, this is typical of presbycusis, old ear. So we tend, as we age, to lose higher frequency our ability to lose hear higher frequency tones at low volumes. And the classic audiogram is the ski slope. Both ears should be pretty much parallel with each other. And it is going to be bilateral. All right, you're supposed to go over the 1.3.1, 1.3.2 resource sheets. Those are going to be the audiograms and the patient descriptions that you did presentations on. And you need to be able to match your audiograms with your patient, and you need to be able to discuss causes and types of hearing loss. You need to know about those different conditions like Meniere's disease, otosclerosis, and so on. Okay, all sounds for speech vibrate at different frequencies, and this is how we differentiate our speech sounds. Vowels are relatively low in pitch, while consonants such as L, M, and M are in the middle range. And then you have the high frequency sounds like S and how would speech understanding be affected by a person with moderate to severe high frequency sensory neural hearing loss? Well, when they're trying to have a conversation, they might get some of those high frequency or words that begin with those high frequency sounds confused, like sun and fun, or feed and seed, or speed. And so they might ask you to repeat yourself, or they might look at you funny like, that didn't make much sense, and they might have to think about it, but yeah. Okay, the cochlea is the organ of hearing. This is where we actually find the nerves that get stimulated to go to the brain. Okay, so the cochlea itself is part of the inner ear. And you remember we had the vestibule, we had the semicircular canals. The cochlea is the snail-like portion of the inner ear. And in the inner ear, you have hair cells called stereocilia. And they are arranged, highest frequency ones are at the beginning of the cochlea. So when you first go from the vestibule into the cochlea, this part of the cochlea is going to have the high frequency hairs, the ones that are sensitive to high pitch sounds. And then as you keep going through the cochlea towards the end point, the sound frequencies are going to get lower. So we would find, if a person has high frequency hearing loss, we would find a lot of damaged hairs in this portion of the cochlea, but not necessarily up here in this portion of the cochlea. And this is just the stereocilia, a picture showing them up here, and how when the endolymph, the liquid inside the cochlea moves, it causes the stereocilia to bend and wave. And that stimulates the nerve that they're attached to, that goes to the cochlear nerve, and then the cochlear nerve goes to the auditory nerve, and that goes to the temporal lobe of the brain. Okay, so that's 1.3.2, and the next part of the study guide will be provided in a timely manner.